Okay, so let's get started on our lab for this week. So lab 5 already. We're to the halfway point in the semester now. So, well, not in the semester, but in our labs at least. So we're moving along pretty well. This week, we're going to be doing a 3D moment frame. So in the weeks past, we've been doing 1 and 2D structures. This week, we're going to be moving on to a third dimension. Generally, when we're designing structures and analyzing them, it's pretty useful to have all 3 dimensions because normally we're, you know, designing 3D structures in the real world. So it's useful to know how to analyze those. So we'll get started with that this week. We're going to be doing a moment frame. So it's similar to Lab 3, except in 3D. So we're going to consider the 3D moment frame shown in figure 1. The model is going to consist of 3 bays in the X direction, 2 bays in the Y direction, and 3 stories. And they're going to have spacings given in figure 1. So if we look at our figure here, we've got 3 bays in our X direction here, 2 bays in our Y direction here, and 3 stories tall here. Make sense? And these spacings here are uneven, so we'll need to go and define our custom spacings in our lab here. And for the loading, we're going to consider that each of the XZ plane frames in our structure, in our 3D grid here, are going to have identical loading as shown in figure 2. So in our 3D frame here, we've got our XZ planes. So kind of along this 3-bay direction and upwards, we're going to have 3 of these planes throughout our building, 1 for each of these column lines. And each of those are going to be loaded like this for the loads in our structure. Any questions on that? Okay, cool. Per usual, we have our units. That's going to be kips and feet. Our material is going to be steel. The section properties we're using are going to be W16 by 77s and W18 by 97s for our beams and columns respectively. And then just like last week, we're going to have dead loads, live loads, and wind loads. And we're going to have those same 2 load combinations we were doing last week. So 1.2 times the dead load, 1.6 live load, 0.5 wind load, 0.9 dead load, and then 1.0 wind load for combination 2 here. And then in figure 3 here, the peak intensities, well, I mean, they're all uniform loads, so they're just going to be 1 kip per foot for dead loads and 5 kip per foot for live loads, basically on all of the beams in those XZ planes. And then we'll have these deliverables that we'll go over. Let's get SAP going. And while that's booting up, does anyone have any questions on premise of the lab or anything in SAP, or I guess anything in the class at this point? It's taking its time today. All right. So now we've got SAP booted up. Anyone need another second to get this going? Okay, so we've got SAP here. We're going to make ourselves a new model, and we'll set up our template to give us our 3D geometry that we are looking for in our lab. Okay, so in our new model window here, first things first is units. So if we recall from our labs here, we want to use kips and feet. So we're going to make sure we select kips and feet from our drop down here. And then the template we want to be using today is going to be the 3D frames template. So that should be the first one on the second row of those images there. So 3D frames right here. So once we've got our units, we can click on that. And this is pretty similar in setup to the 2D frames that we had been doing for the last couple weeks. First things first, we've got this drop down here based off of the type of frame here. So the first one here, the open frame building, is what we're going to be using today. So that's basically just this kind of 3D grid of beams and columns that fills up the whole rectangular prism of the building here. The next one is a perimeter frame building. So this just has that grid of beams and columns, but only around the perimeter of the building. So this is good for like large open space buildings like warehouses or something like that, where we don't necessarily have the structure in the middle there if we've got like a long span roof or something. So there's that one. We've got beam slab buildings, which is basically like the open frame building, but they're including some slab elements in there. We will get to this in a couple of weeks. So this is basically including floors on our frame now as well. So if we want to design the floors to be acting as structural elements in conjunction with the structural frame system, we would use something like this. And then finally, we have a flat plate building here, which is just those floor plates and columns, and there's no beams on the floors there. This is a pretty common construction technique in residential construction nowadays. You'll see it a lot in concrete and post-tension concrete structures, where you'll go and cast the columns, just cast a slab on top of those, and then you keep going up with the columns and another slab. The column distance is short enough, and there's enough reinforcement in the slabs that you don't really need a beam there. This is a pretty fast and economical construction method, so it is pretty popular today. So if you're modeling something like that, this is a good template to start from. But for today, we're going to be using our open frames building. So just kind of our 3D grid here. We've got our boxes here for the number of stories, bays in the X and Y direction, and then our dimensions here. Now this is useful if we have uniformly spaced column lines and stories. But unfortunately today we are dealing with an irregular grid here. So we see our story height changes and our X bay dimensions change here. So what we're going to want to do is we're going to click on use custom grid spacing and then click on the edit grid button. And we will be doing this menu again. So if you remember, we did something like this for the beam. We added all of the grid IDs and the ordinates in our X direction. Now we're doing the same thing, but in all 3 dimensions. So in the X, Y, and Z here. So to get us started, it's useful to know where we want to begin. So what I pick is right here in kind of the very foreground of the structure here. I'm going to consider this as my origin. And we're going to have X going this way, Y going this way, and Z going this way. So they all start at 0 here, and it keeps the whole structure in our positive ordinates. It just makes it all easier. So starting from 0 here, we'll have X ordinates at 15 feet, 15 plus 12, so that's 27 feet, and then 27 plus 15, so that's going to be 42 feet here. So we'll have 4 of those. So the first one is going to start at 0. The second one is going to be 15 feet. third one here is going to be 27 feet. And the fourth one here is going to be 42 feet. Make sense? So 0, 15, 27, and 42. Okay, and then in the y direction, we're going to start with 0 here, and then the next one's going to be at 10, and then the next one's going to be at 20. So we'll start at an ordinate of 0 in column line 1. Our next one is going to be 10, and then the next one is going to be 20. And if you notice in the top right here, we've kind of got a little plan view of our structure, kind of showing us the column grid we're defining. So that's a useful double check to make sure you're getting all your ordinates in the right order, basically. And then finally, we have our Z-grid data. So we're going to start at our foundation here at 0. Next one's going to be at 15. Next one's going to be at 15 plus 12, so that's 27 feet. And then the next one's going to be at 37 feet for the top of the third floor there. So we've got 0 there, we've got 15 feet there. We've got 27 feet in that one. And we need to add another row in this one. So we'll click the add button next to our table here to add that fourth row that we need. For the grid ID, I'll call it Z4 just to keep it consistent with the other ones that are already in there. Doesn't matter what you call it, it's just what you want to name the floor marker, basically. And then our ordinate that we want here is going to be 37. Okay. So any questions on the grid data that we want to put in here? We should have ordinates in our x direction of 0, 15, 27, and 42. Ordinates in our y direction of 0, 10, and 20. And ordinates in our z direction of 0, 15, 27, and 37. Cool. So when we're happy with that, we'll press OK. And we have our grid defined. Now we have two more things we want to do here. First is restraints. That's an easy one to check. Our model here is going to be fixed. So just like last week, I'm going to turn this off because by default, it gives us pinned connections. So I want to remember to make sure I give it the correct boundary conditions. Because like I keep saying, if I don't do this, I will forget. And I'll get the wrong numbers and spend way too long trying to figure out why. Okay, and then finally, we've got our section properties here. So we want to import the W16 by 77 and the W18 by 97 wide flange sections for our beams and columns respectively. So like usual, let's go and click on the little plus button here. We're going to import a new property. It's steel. So we'll go and click on the I/wide flange shape here. We want to click on the AISC15 database here. And then it gives us all of the I-shaped and wide flange members here. So we can scroll down and we can select W16 by 77. And before we press OK here, I'm going to show you a trick. So if you hold Control and go and select other members too, you can highlight more than once. So this is useful if you want to import a whole lot of different sections into your model. You might not necessarily be using all of them at the same time. Like if you're trying to test a whole bunch of different sections to see which ones are giving you like the deflections you want or something like that. So this is useful. You can import multiple at a time because up to this point, we've been importing like one at a time. It works either way. This way I can save you some clicks if you want to bring in more than one. So let's click on 16 by 77 here. Let's press Control and then also click on 18 by 97 here. And then we can import both of these at the same time. Make sense? And once we've got both of those selected, we'll press OK. This will show the last one we selected in our list here. We don't need to change anything here, so it's fine. So we just press OK. And now we see that we have the 16 by 77 and the 18 by 97 shape in our imported properties here. So we'll press OK. And then we go and assign the 16 by 77 to beams here and the 18 by 97 to the columns here. And then our template is ready to go. Any questions on that? Cool. So let's press OK. It'll generate our template here. And we see we've got our 3D frame. We've got this one and a plan view. I'm going to close this one. It's the 3D structure, so I'm going to work in 3D today. And we see we have our structure here. We have our origin down here, X direction, Y direction, Z direction. And if you recall from how I was talking about how we move around in the program from a couple weeks ago, we can pan by either using this little hand in the bar at the top here that's called pan, or holding down middle mouse button. Those will both do the same thing, so you can kind of drag it around statically to different places on your screen. And if you want to rotate it, you can press Shift and hold down your middle mouse button, and that will do a 3D rotate around the kind of center of gravity of your structure here. Uh-oh. There we go. If you need to zoom in and zoom out, these magnifying glasses here work as well. If you go and zoom yourself off into some remote corner of the environment and can't find where you placed your structure, there's this one right here called Restore Full View. It's got the kind of solid circle inside the magnifying glass there. That's really useful. That brings you back and it centers your view on the structure. So just in case you accidentally manage to zoom way in and get lost or something like that. Okay, so we have our structure here. So first things first, let's navigate ourselves around so that we can select all 12 of our column bases here. So let me do that. Let's drag and select all 12 of those. In the bottom left, it should say that we have all 12 points selected. And then we will go to Assign, Joint, Restraints. And then we'll click on our fixed support and then press OK. Okay, any questions on this so far? Okay, cool. So next thing we want to do is we want to set up all of our loads. So like last week, we want to set up our load patterns and then set up our load combinations. So to do that, we're going to go to Define. And then we're going to go down to Load Patterns. And we already have our dead load in here. So let's add ourselves a live load and a wind load, just like last week. So I'll put in live here, change the type to live. Self-weight multiplier of 0 is okay. So then we press Add New Load Load Pattern, and it adds it to our table here. And then we'll do the same for wind. The type we'll set to wind. Self-weight multiplier of 0 is okay. And then we want to set this last box to none. And then when we're happy with that, we say Add New Load Pattern. So we've got our dead load, our live load, and our wind load here. All good with that? Cool. So we'll press OK there. And now let's add our load combinations. So we'll go to Define, Load Combinations. And then to add our combos, we press Add New Combo. So for combination 1 here, let's start with the dead load. That's going to have a scale factor of 1.2. We'll add that. The live load is going to have a scale factor of 1.6. We'll add that. And then our wind load here is going to have a scale factor of 0.5, and we'll add that. So load combination 1 is 1.2 dead load, 1.6 live load, and 0.5 wind load. And then when we're happy with that, we press OK. Anyone need a second? Okay, so we'll press OK here. And then let's add another combination. We're going to select dead load here. The scale factor for that is 0.9. We'll add that. And then for wind load, our scale factor is going to be 1.0, and we'll add that. And then once we're happy with this load combination, 0.9 times dead load, 1.0 times wind load, we press OK. And we have our 2 load combinations set up. Press OK there. And now we're ready to start assigning loads to our structure. Any questions? Yeah? Uh-oh, what's going on?
What did you do?
Okay. So you're in the VCL. There's a bit of lag on the VCL when you're rotating around in 3D. So let's stop moving on the mouse there. Let's go and click that magnifying glass, just the button there. Yeah, that one. That'll restore your view to your structure there. And I think you should be able to interact with it now. What tool do you have selected? Press on pen there. Let's okay, do that. And try the arrow key. Okay, there you go. If you're using the VCL, there might be a little interesting interaction with the extra software layer on top. So might need a little extra troubleshooting there. Okay, so now that we're all ready with this, we've got our load set up, we've got our combination set up, we can start applying our loads. So we want to orient our structure in a way where, like this, I find is pretty helpful for how I want to select the loads here, where we can go and select all of the beams in our kind of X, Z view here in all 3 of these frames that are in the Y direction there. And once we have those selected, we should have 27 frames selected. So you can read that in the bottom left there. Make sure you've got everything selected that you want.
You had it, the top one, the middle one, or I guess the first.
Yeah, for all 3 floors here, all 3 of them going back.
Okay.
And in all 3 bays.
Okay,
36. I think you might have selected something else along with that too. So if you are seeing the ones I have selected here, it's just the ones going kind of along this X direction on the floors here. Okay, yeah, we don't want the side ones. We just want, they should all be parallel to each other. Okay, any questions on which beams we should be selecting here? Okay, cool. So once we have those selected, let's do our dead loads. So that's going to be 1 kit per foot. So we'll go to Assign, Frame Loads, Distributed. We'll make sure our load pattern's on dead load. And then our uniform load should be 1 kit per foot. And then we'll press OK. And we see we have our frame distributed dead loads here. And if we look around our structure, we have our 1 kip per foot dead loads on all of these beams, basically. So does that make sense where all of those are? Okay, so once we've done that, we can now do our live loads. So we can go and select those same frames again. Or I can, because these are the exact same frames that we had selected last time, there's a shortcut. We can press Control J, and that gives us our last selection. So that's actually really useful if we need to be doing repeated stuff on a selection of members. So that's a neat one. I learned a couple years ago and was like, where has this been? So we can use that one to select all 27 of those same frames. And then we can go to Assign, Frame Loads, Distributed. We'll change our load pattern from dead to live. And then our uniform load is going to be set to 5 kips per foot. And then we'll press OK. So now again, we see we have our frame distributed loads, but for our live load this time. And we have our 5 kip per foot loads on all of those beams. Make sense? Okay. Anyone need a second to catch up? Okay, so let's keep moving. So the last thing we want to do is we want to add our wind loads from our structure here. So those are going to be these 10, 20, and 30 kip loads applied as point loads on these 3 sets of frames. So what we're going to wind up doing is applying 9 point loads to that one side of our structure here. So for the bottom 3 here, let's select those 3 nodes, and we're going to apply a 10 kip per foot wind load on those. Or sorry, just a 10 kip wind load on each of those nodes there. So we have those selected. We're going to go to Assign. We're going to go to Joint Loads. We're going to go to Forces. And then instead of dead at the top here, we're going to select Wind. And then in Force Global X here, because those forces are going in our positive global X direction, we're going to put in 10 kips. Press OK. And now we have our 10 kip loads on our first floor here. And we'll do the same for the next 2 floors, except for 20 and 30 kips for each of those. So we'll select all 3 on the second floor here. We will go to Assign, Joint Loads, Forces, make sure it's in the wind load case. We want that to be 20 kips. Press OK there. And then we'll do the same thing for the last floor. Select those 3 nodes, go to Assign, Joint Loads, Forces, make sure it's in the wind load case, and then use 30 kips in the Force Global X direction and press OK. So we have our point loads for our wind loads there, and we also still have our distributed loads. They're just not being displayed right now because it's looking at our wind loads that are applied at nodes right now. Okay, any questions on modeling the structure or applying loads? All going well? Wonderful. Okay. One last thing. Not that we need to do it for this model, but it's a useful tool you might want to know about. Up in the toolbar here, you see there's this pair of sunglasses. This is called perspective toggle, and this switches the drawing style here from a like a 2-point perspective view to some type of orthographic perspective view. So if we click that, it changes the perspective of our structure here. So this one, like all the parallel lines stay parallel in all of their axes here. And that is useful in some circumstances, like if you want to line everything up to make sure you can select it all really neatly. It's a really good use I've found for that. Though, if you're looking at it in 3D, sometimes you start getting into that optical illusion type state where you're like, okay, what angle am I actually looking at this from? And so you kind of have to give yourself some rotation there to just double check. Or you can switch your perspective, and that I find that's a less common thing that happens to me, at least. I I don't lose the perspective in this one quite as much. So they're both interesting modes to work in. Both interesting tools. You might find it useful in some circumstances when you're navigating around your model to be able to toggle your perspective between those two modes. Okay, so we've set up all of our geometry. We've set up all of our loads. So now we can run our analysis. So we'll run the analysis. We're going to make sure our modal case does not run, but we want to make sure our dead load, our live load, and our wind load cases all run, because that's how SAP goes and does the load combinations. It will run an analysis using those dead loads. It'll run a second analysis using the live loads, and it'll run a third analysis using the wind loads. And then it'll take the results from each of those analyses, scale them by those scale factors, and then combine them all using superposition. Because this is a linear system, superposition works. So it's actually a really clever use of that to go and handle all these load combinations here. If we get into nonlinear stuff, it breaks down a little, but for these cases, it works pretty well. So anyway, make sure dead, live, and wind all run, because if we accidentally set one of those to not run, our combinations won't generate. So let's hit run now. It'll want us to save it. So we'll make a folder. We'll save it in there. It'll take just a second to run the model. And then when it's done, we'll get our deformed shape for our structure here. And we see we've got a bit of a squished looking dead load combination here. Okay, any questions on that? Everyone getting something that looks like this? Anyone getting something different? Cool, we should all be on the same page then. Good. So once we've got this, let's look at our deliverables. So the deliverables we want to be doing today, we want to look at our reactions, our deformed shape, story drift, shear diagrams, and moment diagrams. Same thing as last week, but because we have another dimension now, we have a little bit more we need to double check when we're putting a deliverable together. So for the reactions, we want to find it for each support with values and arrows for the XZ frame at y = 10, subject to load combination 1. So first things first, we want our reactions subject to load combination 1. So we've done that before. We'll just go up here, go to joints, make sure we select combination 1, and then we can press OK. Now this will give us all of our reactions here, and that's a lot of reactions. We've got, I think there's 72 reactions there. We've got 12 supports, and each of them has 6 different reactions. So there's a lot of numbers there. And this is getting to the point where it's kind of crowded, and if you turn this in a report to your boss at your job, they're probably going to be like, what's this? Organize this a little better. And one way we can do that is we can kind of take our structure here and we can take 2D slices of it. So for the report, this one's asking us to look at the 2D slice in the XZ direction for at the Y coordinate of 10. So that's going to be this kind of middle section of the columns here. And the way we do that is let's put our section in an XZ view here. And then we're going to go up to view here. And we're going to go to set 2D view. Or we can do Control Shift F2 if you're really into your shortcuts, if you're doing it a lot. So we'll set our 2D view here. And in this menu, what we want to do is we want to set the XZ plane. So that's this middle option here. And then on the right here, our Y we need to set to 10 feet. Oops. Yeah, so we should have XZ and then set Y is equal to 10 feet here. And you see in our picture on the top here, this is like the plan of our structure with all of the columns kind of circled there. And this red line is kind of that section cut we're making across our plan here. So we're going to be looking at this middle column line right here in section. Make sense? So make sure XZ is here and then make sure it's 10 here. And then we press OK. And then this will give us our reactions at that middle row of columns there in this 2D view. So this is what you'd want to take a screenshot of for the report. Okay. Yes.
I'm still getting like the 380 like version of it. I just think it's high end work.
Hit the set XZ view button up here first, and then try setting your 2D view after that. Does that work any better? Let's see.
Right. I guess it was getting pictures.
Yeah, the new graphics kind of puts numbers how to be for the places that so it doesn't matter too much, but that does help it with readability. Okay, so that's reactions. Next thing, let's do our deformed shape. So the deliverable we're looking for here is our deformed shape for the XZ frame at Y equals 10, subject to load combination 2. So good news, our 2D view is already in the XZ frame at Y equals 10, so we don't need to change that for this one. But we want to look at our deformed shape for load combination 2. So that's pretty easy. We'll go up to our button up here for show deformed shape. We'll click on that. In our case/combo name here, we'll select combination 2. And then I like wire shadow, so I'll select that. And then we'll press OK. So here's our deformed shape for combo 2 there. Everyone getting something like that? Perfect. All right, and then for deliverable 3 here, we're going to be doing story drift values again. So this one's asking for the story drift values for the right bay of the XZ frame at Y equals 20, subject to load combinations 1 and 2, and the ratios of combinations 2 to 1. So let's set our view to Y equals 20. So we'll go to View, Set 2D View, and then we'll change Y from 10 to 20 here. Like that, we can see that our red line has moved all the way back to the last column line there. We can press OK. Our deformed shape still looks the same because our structure's pretty much loaded the same on all 3 of those bays, or all 3 of those column lines there. But what we want to do here is we want to look at our drift values for our first floor, our second floor, and our third floor. So that's going to be U1 for each of those. And we're in combination 2 here. So we go and note down those 3 values. Let's go and look for combination 1. And we'll go and note down that U1 value, that U1 value, and that U1 value. And then you go and do the combinations of them again. And again, they should be at about 2. So any questions on the drift values, what we're looking for here? Same thing as last week, except we just, only difference is we need to pick one of those frame sections to do it on, basically. Yes. Oh, you can just write those down. Yeah, just make a table. Combination 1, combination 2, ratios 1, 2, 3. That's all I need. Screenshots are great when you got like geometry and like a lot of numbers. If it's like one number we need, that's just easier to write that down than taking a whole screenshot of it. Plus, we know you're looking at the right number, so you're not like saying, oh, R2 is my drift value. Okay. So next is the shear diagram. So we're going to do that for the frame at y equals 0 for load combination 2. So let's set our 2D view to y equals 0. So we see it's right there going through the origin. And then press OK. And then we want to display our shear value. So let's go to show forces and stresses here. Goes to frames, cables, and tendons. And then it said for combination 2, right? It did. We'll go and select combination 2 right here. We want to select shear 2, and then we want to say show values right here. And then we'll press OK. And here's our shear diagram. So not too bad considering the complexity of the structure so far. So we can always do the object shrink toggle to go and pop out the numbers a little bit if we want to. And then we wanted to also find the maximum shear in the second story columns of the XC frame. So we want to look for the maximum shear in these columns right here. So we've got 10.39, 15.66, 16.49, and 7.46. So the maximum shear value in these second story columns here is going to be controlled by this one at about 16.5 there. So that's going to be in kips. So that's good. And then we want to do the same thing for the moment diagram. Same everything else except instead of shear, it's moment. So let's just go up to here, show frames, cable, show forces and stresses, frames, cables, tendons. Instead of shear 2, we click moment 3, and then we press OK. And now we've got our moment diagrams. So kind of all on top of each other there. So the object shrink toggle helps us read it a little better. And then if we want to find the maximum moment in these second story columns here, we can take a look. This one's got a max of -75. This one's got a max of -101. This one looks like it's -105. And this one's got a max of -58. So let's just double check in here. Our maximum moment it's going to be in that same column as our max shear was in, which makes sense. It's going to be -105.7 kN. So we want to note that down in the report too, along with our diagram of the frame here. Okay, any questions on the deliverables there? Cool. So that's lab 5, pretty similar to last week, except we're adding a whole new dimension. Cool. So thanks for coming this week, and we'll see you next week. Have a good one. For sure.